Hello friends, SimPilot here. I hope everybody is doing great. Greetings to all of you from my end of the screen. Welcome back to another tutorial. This is episode 5.2 of my tutorial series for Microsoft Flight Simulator and flight simulation in general for new flight simulers or beginner flight simulation enthusiasts. In this tutorial, we will be looking into IFR flight planning using SkyVector, departure and arrival charts and seeing them side by side along with our flight plan, as well as approach charts or approach plates and how to read them. This tutorial series are designed to build on knowledge from the last episode, so if you haven't done already, I suggest you to go and watch the previous episodes before watching this one. Everything will make more sense if you do so. And please don't forget to give me a thumbs up if this tutorial is helpful to you, and don't forget to subscribe and turn on the notifications to get notified for the future episodes if you haven't done already. So this tutorial was requested by Norberto. I know I promised to go and start working on G3000 and turboprop aircrafts, but I decided to do an advanced tutorial about SkyVector, which will also tie into the future episodes, and everything will make more sense when we move to the more advanced aircraft that can travel at higher speeds and altitudes. It will become important to read the charts and understand the instrument flight rules in general. And hopefully by watching this tutorial, you will have a better, if not more, information about IFR. So we are looking at SkyVector map here, and let's start with what more information is presented to us in SkyVector. I will zoom in a little bit and try to locate a big airport, and this should work for any airport, but let's just take a look at Sky Harbor International at Phoenix, Arizona. When I hover over to the airport, you see a yellow box popping and showing and saying that weather station Phoenix Sky Harbor. This box gives you the current weather information at that airport, which is important for flight planning, either it's real life flight planning or flight simulation. The first set of numbers you see after Kilo Papa Hotel X-ray, which is the ICAO code of Phoenix, is the Zulu time at this moment. So that's 10:00. 51 is the seconds, so 10:00:51 Zulu is the current time at Phoenix, or current time at the moment. The second set of numbers, where you see 200:04 KT, is the wind information. So that means the winds are blowing or coming from 200 degrees and at 4 knots. So that means this black line of this VOR station is pointing to the magnetic north, which is 0 degrees or 360 degrees. The opposite of it, which is this arrow, is 180 degrees. And if I go, each line will represent another 10 degrees, so 180, 190, 200. So that means wind is coming from this direction at 4 knots. And sometimes you get a G after that 04 or 4 knots that says, or that gives you information about the gusting winds, and it will have a different speed. I don't know, maybe we can just take a look at other places and see if I can show you this. Yeah, right over here. So if you see 020 at 11, that means the winds are coming from 20 degrees at 11 knots and gusting at 17 knots. So that's another information. So that means at the moment at Phoenix, we don't have any gusting winds. It's just calm winds at 4 knots. When you follow along, the other information is about cloud layers and whatnot, and the visibility is clear, so on and so forth. The one that starts with an A, which says A2975, that is the barometric pressure in inches mercury. So United States is using inches mercury, and European region is using hectopascals. And that is your altimeter setting. When you load into the cockpit, you need to set your altimeter to 2975 to have a correct reading of the ground elevation or current altimeter values. So this is the weather information and altimeter setting that you can get from SkyVector easily by hovering over any airport that you see on the map. What else we have? There is a layers menu here. When you open that menu, you get to see a lot more information as overlays. So when I click this, it says icing. So I should expect to have icing around this region if I'm traveling towards this region. So that's a good idea to turn on my de-icing systems in my aircraft if I am planning to fly towards here. Although I haven't tested this in the simulator, but I am assuming while Microsoft Flight Simulator is using live weather, this should hold true. So if you test it and if it holds true, please let me know in the comments whether it's true or not if you come to a region where there is icing possibility. The other one is the turbulence. So it is going to show you the turbulence. So you should expect to see turbulence around these regions if you are traveling around here. So that means if we are departing from Phoenix, we should expect to see some turbulence. Because of that gusting winds around, they will create some air pockets that will end up creating turbulence around the aircraft. This box is going to show you where you should follow the instrument flight rules at the moment. But I'm not going to dive into deep detail on this. And this one, mountain obscuration, is showing you where you should expect to see mountain ranges. And if you remember from the last episode, when we look at the numbers on the map, if I switch to World Blau, you remember these numbers? These are the minimum obstacle clearance altitudes around this sector, and they are all above 10,000. That means I should expect to see mountains around here. What else you can get? You can get the cloud coverage. You can get the satellite cloud information. And you can get the weather radar information, like where is rain and snow or weather events like that. The last thing I want to show you is, let me get close to Phoenix, is these wind barbs. So when you click this, it will fill your map with the wind barbs, and these lines at the top is showing the strength of the wind. So one line is like calm, 2 is a little bit strong, 3 is stronger, so on and so forth. Okay, and this is showing the direction of the wind, so that means the wind is coming from this direction at the moment. And there is a setting here where you can check the surface level or go above and check different altitudes to get wind information at different altitudes. So let's go back to surface maybe, and this is showing the current Zulu time, and you can look ahead as well if you scroll this slider, move it around. So now we know at Phoenix the winds are coming from 200. So 200 was 180, 190 here. So I should expect to see the wind barb showing this direction if I move it a little bit above surface probably. Okay, whatever. So that's showing the direction of the wind and the strength of the wind, if you are interested in that information. So I'm not going to try to demonstrate it. I want to keep the video at a reasonable length. So that's what information you can expect to see using SkyVector. The other one I want to show is, you remember we discussed the Victor Airways, the low altitude airways, and what black lines and blue lines and brown ones mean. I want to go in a little bit deep detail. So in the United States region, when you see these black lines at the high altitude airways, These are called jetways. So this one is jetway 18-102. This one is jetway 65. So these are non-RNAV airways. In other words, you can fly these airways perfectly by using VOR stations. On the other hand, when you look at these blue ones, these are called Quebec airways, and they are GPS or RNAV airways. So to travel these airways, you have to have a GPS-equipped aircraft. And the symbols you see in the waypoints are different than you see on the black ones. These are waypoints for VOR stations, and these are the symbols for the VOR stations. This different symbol is representing the GPS waypoints. Okay, so that's the next information I wanted to share with you. And when you go over to the European region, their naming convention changes a little bit. In Europe, if the map can load, these are called U or Uniform Airways, which means upper airways. And they have different classifications and naming conventions. I found a good Stack Exchange post about this. I will put the link to the description if you are interested in reading that post about the European Airways and United States Airways and their naming conventions and how they are classified. Okay, so now the main purpose of the tutorial, flight planning and charts. Let's zoom in a little bit and try to find Phoenix Airport one more time, which is right here. So our flight today is going to be from Phoenix, Kilo Papa Hotel X-Ray, to Kilo Lima Alpha Sierra, which is Las Vegas International Airport. Okay, and like last time, I am going to pick up a route, and I will pick the most fuel efficient route at the top. And now, as you see, now we have a visual representation of our route or our course. Let's keep it like this. So now let's take a look at the charts. I will start with the airport diagram, and I will rotate this so that you can see it better and maybe resize it a little bit and get closer to Phoenix. This airport diagram shows you the alignment of the runways, and when I rotated it like this, it is exactly how Phoenix is laid out on the map. This side is east, this side is west, north and south, and these runway alignments are perfectly aligned with the airport on the map. So the runway headings, right? So this is runway 26 and its heading is 260 degrees. So that name is coming from the runway heading. This one is runway 25 right, and the heading is 26. So if I maybe go and find another information about the airport, I can explain it better. Maybe just the departure procedure that we see here, ZEPAIR 2, will give us some more information about the runway heading. So ZEPAIR 2, as you see, ZEPAIR 2 is an RNAV approach. That means to fly this approach, my aircraft has to have a GPS on board. Alright, so right here, so this is runway 26, 25 right, 25 left. And as you see, the runway headings are 258 degrees, and it is showing 260 here. So that's how the runways are named. If you have three runways facing the same direction, you name one of them 26, the other one left and right, and it's coming from this. You round this up to the nearest 10 and you round this down to the nearest 10, and that's how you name your runways respectively. The other side is runway 8, runway 7 left, runway 7 right, and that's also coming from these headings, 078. Rounded up, that gives you 080, which is this one right here. Rounded down, that's 070. And you have two of those, so one becomes left, that's on the left, and the other one becomes the right, which is on the right. You also get to see the runway elevations from this airport diagram. This side of the runway is 1,135 feet. This side is 1,111. So that means this runway has a downslope from here to there. You also get to see the taxiways on this diagram. So when you are instructed by ATC to follow, let's say taxiway Charlie, Charlie 8, Bravo, Bravo 13, that's how you find your way and how you are going to taxi to the runway that you will be departing from. So now let's close the airport diagram and let's start to take a look at the departure chart. So the departure charts, or departures in general, if I want to, use some sort of analogy, you can think of your departure like your route out of a parking lot with your car. So that means you have to take all these waypoints all the way to the exit, which is this RRSTA. And let's just open, this one has a second page. Where was it? Departure, Zephyr 2 continued, right there. So let's put them side by side so that we can take a look at these together. Takeoff runway 26. We are going to take this as an example. Runway 26 is this one. It says climb on heading 258 to 1635, so 1635 feet. And you also see it here, and there is a line under that 1635. So that means you need to be above this altitude right here when you are traveling towards this waypoint. And then after 1635, directly to Vivla, then on track to 260 to Hirvu. Then turn right to 349 to cross Z-Dog at or above 5,000. And if you take a look here, that 5,000 has a line under it. So that means I need to be at or above that altitude. And it keeps saying at or below 230 knots. So this is also giving a speed reference or speed restriction, saying I have to be at 230 knots or below, and that line above that number tells me that I have to be at or below this speed when I hit here or when I reach to this waypoint. And it says after that track 344 to Fenon and then 333 to Zephyr. And if you take a look at here, each one of these departures are directing you to Zephyr, and then thence it's same for each departure on RRSTA transition. So a transition means, like if we use that same analogy, this is your waypoints to the exit of that parking lot, and this is your exit point. That after here, that means you are going to reach the road and go wherever you are going to. So that's transition in aviation. It says maintain 8,000. So when we come to RRSTA transition, we have to maintain 8,000 after Zephyr and expect higher altitudes 3 minutes after departure. So that means after 3 minutes, the ATC will give us higher altitude clearance at about 3 minutes after departure. And we might be at a higher altitude when we reach to this waypoint, because if you hover over here, that's a 100-mile departure, so that's a long distance. And that's why these instrument departures are for faster aircraft, not for a Cessna 172. You can also fly this with a Cessna 172, but I don't think they will let you to do it in real life. In simulator, I think it's fine to do it, but it will take too much time with the Cessna 172 to just fly this departure, because it's going to take roughly an hour of your time if you do this in a Cessna 172. So that's the departure chart and how you read it. This one is your visual depiction of the departure, and this one is the instructions of each departure written in text format. And you have some takeoff minimums saying you have to climb at least 500 feet per nautical mile to 1635, and then minimum 240 per nautical mile until you reach 5,300 feet for runway 7 left, right, and 8 departures. For 25 left, 25 right, and 26, it stops at 1635, and you have to follow this for your altitude restrictions. Okay, so that's the departure. The other thing I want to show is you can actually type this into your flight plan. If I clean and get rid of that Zapier here, let's start typing. What was our first waypoint? Vivla. Second one, Hirvu. Third one is Z-Dog. And I forgot a space there. Fourth one is Feinen. Fifth one is Zapier. And the last one, the one before last is Misa. And then the last one is RRSTA. So I want you to take a look at this line when I hit enter. As you see, nothing has changed, but now I see my waypoints depicted on my route after entering them into here. Let's close this and let's close this. I think this is enough information about how to read the departure chart. Let's take a look at the arrivals. So we have to go and click Las Vegas International or McCarran International and find the standard terminal arrival. So these are also called STARS, standard terminal arrival routes. Respectively, the departure is also called or known as SID in aviation, standard instrument departure. Let's find that one, and we are using Tyson 5 as our arrival, which is right here. And as soon as I take a look at the name, I see that RNAV next to it. That means random navigation, so that means this is a GPS arrival. I cannot fly this arrival with using my VOR radios or navigation radios on board. Alright, let's rotate this and resize this so that we can see it a little bit better. And let's put them side by side. So we are coming from here, and that's north. So we are coming from southeast of that airport. So we will probably see something like this: Kingman, IGM, IGM. That's exactly where our arrival starts. So same analogy, parking lot, this is your entrance to the parking lot. Let's say you left this parking lot, hit the road, drove all the way to here. Now you are entering to a different parking lot. So that's your entrance point. In other words, this is your transition. And it says Kingsman transition here. And the other one, Lorraine transition, Peach Springs transition, which is, I believe, right here. And then Drake transition is right here. So we are going to use this Kingsman transition because we are coming towards here. Okay. Now let's see what it says. It says Kingman, flight level 200 or above. So that means I have to be above or at or above 20,000 feet at here. And Zetis below flight level 190. So that means I need to drop 1,000 feet in 15 miles. And same goes for here when I reach here, and you see double lines for both speed and altitude. This means I need to be exactly at 12,000 feet and at 250 knots. So that means if I am faster, I need to slow down. And I need to drop my altitude and descend to 12,000 feet. So that means if I was at 19,000 here in 22 miles, I need to drop like 7,000 feet to 12,000. So how you calculate your descent? There is a really easy way to do it, and it works for most of the time. You take your speed. Let's say if I am at 300 knots when I was here and at 19,000 feet, divide your speed by 2. So 300 divided by 2 is 150. And put a 0 at the end. That makes 1500. So that means I need to descend at a rate of 1500 feet per minute to safely come down to this altitude before reaching that waypoint. So that's an easier way to calculate it. And there is another way of calculating it when you should start to descend, but that's a subject to another tutorial. So let's keep going. Caddy, 12,000 feet, 250 knots. Tyson, no restriction, but I still see 10,000 here, so it's better to start descending to 10,000 because that 10,000 is also here. And when I hit Susi, Sierra Uniform Zulu Sierra India, it says I need to be at 10,000 and my speed needs to be 210 knots. Okay, and I see 8,000, and at Prino I have to be at 8,000 feet. So this means I will keep descending all the way from 19,000 from here all the way into 8,000 before I hit this waypoint. And this is my entrance to the runway, or this is where my approach starts. If we pull the approach chart, Prino will show as probably our initial approach fix on that chart, and I will show you what I mean by that here in a second. Let's pull the approach, and if you read this text while I was speaking, it says cross Prino at 8,000, runway 26 left, intercept the runway 26 left localizer. All other runways expect radar vectors to final approach course. So that means I can use this on my own to approach or to do an ILS approach to runway 26 left. But if I am intending to land to a different runway, I have to expect vectors from the ATC to direct me to that runway. So this is 26, and let's just pull the 26 left ILS approach here. And let me switch the windows, put this here, maybe make this a little bit smaller, and close this one so that we see it side by side. So, and in fact, before we just take a look at the approach chart, I can also type this into the flight plan up there. So after Kingman, my next waypoint is Zetas. From there it is going to be Caddy. After Caddy it is going to be Tyson. After Tyson it is Susi. I butchered that one, I know. And then after Susi it's Prino. And when I hit enter, nothing changes, but I get the waypoints depicted on my route. I think we are done pretty much with the STAR standard terminal arrival route. I will keep it there, but I will take this and move it over that one to have more screen space. Let's take a look at the approach chart, because this is the hardest one to understand, if you ask me. So start from the top. Let's start from here. This is your localizer or ILS frequency, 111.5. Okay, you tune this to your nav radio if you are flying with an aircraft that has G1000. Otherwise, G3000 and airliners and other aircrafts can do this automatically when you put your flight plan together using the unit itself. Alright, over here I'm not going to explain this. This is not important information for flight simulation. But this one over here says missed approach. So this is your missed approach procedure or missed approach instructions. Climb to 3100 and then climbing right turn to 7000. So that means I will climb to 3100 and while doing a right turn, keep climbing to 7000, direct to BLD VOR TAC, VORTAC. And that VORTAC is right here, Boulder City VOR. So that means I will track that and this radial 287 until I reach here. And then I see a right holding pattern. This is called the right holding pattern because it's to the right of that VOR station. I enter it from probably here. Or if I have to do it, I will come down to here and enter that pattern from here, rather from here, and do a clockwise holding pattern over here. So that's my missed approach, and I will wait for the ATC to instruct me and give me vectors back to my initial approach fix. And if you remember, I told that Prino is probably our initial approach fix, and I see it over here, IAF, initial approach fix, is here, and 8,000 feet is my initial approach altitude. From there, this map here is your horizontal navigation into the runway. This is showing you your horizontal profile. And this circle here which says MSA, LAS is Las Vegas VOR station, and it says 25 nautical miles. So this circle is a 25-mile radius circle, and MSA means minimum sector altitude. So that means if I'm coming from east, I need to be at least at 6,700 feet to safely travel through this sector, because minimum sector altitude is 1,000 feet above the highest obstacle around that sector. And I'm assuming it is because of this mountain here, which has a summit of 5,445 feet. Okay, if I was coming from north, my sector altitude or minimum sector altitude becomes 10,200 because of probably that mountain range right there, because it's starting at 3,000 feet and it's probably much more higher than that. Same goes for coming from west, and it is 13,200. And when I'm coming from south, it's 8,400 when I'm coming from this direction. So this is your minimum sector altitude that covers 25 nautical miles around this VOR station. Okay, so I think we covered this information. You also get your VOR station frequencies, your localizer frequency, the other localizer and its frequency, and these dots and dashes, these are the Morse codes transmitted by these VOR stations, and you can literally listen to them in your aircraft. I can show you how in the next episode. Okay, when we move down to here, this is the information about the runways, and you see TDZE. This is your touchdown zone elevation. So 26 left has a touchdown zone elevation of 2,069 feet. What I mean by touchdown zone elevation is this right here, where you put your wheels on the runway. That's called the touchdown zone. And it's also written over here, touchdown zone elevation 2,069, airport elevation 2181 for 26 left, and that's probably same for, because it's the airport elevation for 26 right, but the touchdown zone elevation is different for 26 right. Okay, and this section of the runway diagram shows you your final approach fix to missed approach point and the distance 5.3 miles. If we take a look at this side section here, This is your vertical profile or vertical navigation into the runway, while this is your horizontal, this is your vertical one, so that you see them side by side or, in the same page. Pre-know, you start at 8,000, you descend down to 6,500 at Larray, you descend down to 4,900 at Shand, and when you come to here, Relin, you see this. This is called this is called a Maltese cross. So this is the identification of your final approach fix. That, in other words, this is going to be your final waypoint for your approach into the runway. From there, and this is where you should expect to capture the glide slope. You see this lightning symbol here, it says 3,800 or above. This is where you should expect to capture the glide slope, and you need to be at this altitude to capture it properly. You can capture your localizer here, which will keep you in line with the runway, but you will not see the glide slope coming live until you hit this waypoint and this altitude. That's what it's trying to say, in other words. And the missed approach point from final approach fix is from here to here. 4.1 plus 1.2 is 5.3. So that means this is your final approach into the runway, and this is where you should think about making a missed approach call, or go around call right around here at this last 1.2 miles, and this arrow represents your short final into the runway. Okay, the other information you see here is your speed table, your speed in knots, and how many minutes and seconds it will take from this waypoint, which is your final approach fix, into the runway. And that goes along with this information here. This is your minimum decision altitude or minimum decision height that's written in parentheses. These categories are aircraft categories. A is for single prop aircraft or single engine like a Cessna 172. B is for dual engine aircraft like a Diamond DA62. C is for Airbus A320s, Boeing 737s, commercial jets or business jets. D is heavier aircraft like a Boeing 757, Airbus A330, and E is for very heavy aircraft like a 747 or A380. Okay, and if you are doing an ILS approach to runway 26 left, all aircraft types needs to use this decision altitude or decision height, minimum decision altitude or minimum decision height. This is your minimum state you set to your GPS or navigation unit in your aircraft. What this means is this is a reference point. When you see 200 on your altimeter, you have to have a visual confirmation of the runway. If you don't see the runway in front of you at 200 feet, that means you have to do a go around and execute a missed approach procedure that's described here. If it's a localizer approach, not an ILS, that minimum becomes 451 feet. So if it's a localizer approach at 451 feet, you need to have a visual of the runway for this class of aircraft. And that's same for this class of aircraft too. So that's the approach chart for you guys. And this is pretty much what you should expect to see on an approach plate and how you should read it and understand what it represents. Just to point some key points, your localizer frequency, your minimum decision height or minimum decision altitude will be important. You will set this as a reference point. And your initial approach fix, where you should expect to capture the localizer, and your final approach fix, where you should expect to capture the glide slope. Okay? Alright, I think this is going to be it for this tutorial. By the way, you can also keep typing these waypoints into here, like after pre-know. Larray, Shand, and Relin all the way until your final approach fix, and it will show you those points on the map. Okay, and you can take a look at the airport diagram, which is pictured here. Oh, wrong airport, sorry. And that's exactly what you see here. And this also gives you the taxi routes and taxiways and runway elevations and runway headings, so on and so forth. And if you remember from our discussion last time, runway heading is 258 and runway name is 26 right. Runway heading is 258, runway name is 26 left. And runway elevation is 2033, 2048, respectively on the other end of the runway, 2157 and 2179 for this runway. And if you take a look here, it says it has a 0.9% slope going up. So that's we found this information for Las Vegas Airport, but this information was probably not there for Phoenix Sky Harbor. So that's another good information for you guys on the airport diagram. Alright friends, this is going to be it for Sky Vector. I think we covered pretty much everything that we need to cover for flight planning and charts and how to read the charts and how to plan our flight, so on and so forth. Please leave me a comment down below if you have any questions. And please don't forget to give me a thumbs up if this tutorial was helpful to you. And also don't forget to subscribe and turn on the notifications for future episodes if you haven't done already. I will be probably publishing another episode later this week, potentially Friday night. And this time I promise we are going to start looking into G1000 and turboprop aircraft in Microsoft Flight Simulator. Please stay safe, and I will see you in the next video.